first of our concept check questions on IR spectroscopy gives you a molecular formula and 2 key IR stretches and asks you which structure could correspond to the data. Let's look at the formula first this time as a quick way to distinguish between the structural choices given. This formula corresponds to an unsaturation number of 3. So right off the bat, I favor the third structure shown. But let's also look at the IR stretches and make sure they're consistent with this assignment. A vibration at 2215 wave numbers is indicative of a triple bond, an alkyne or a nitrile. A vibration at 1646 is indicative of a carbon-carbon double bond, an alkene. Both of these are consistent with the last structure. And if you favored the first or second structures, you should note that these would both show NH stretches around 3300 to 3600, which is not present in the spectrum. So the third structure is our best choice, and it's the only choice that's consistent with all of the data given. In the second question, we're given only the IR spectrum and some compounds to choose from. Here we'll be looking for key stretching frequencies. I'll start at the left side of the spectrum, and here I see a broad peak in the region of an NH or OH stretch. It's broad, and so I favor that to be an OH stretch. Then moving to the right, I have what looks like a CO double bond stretch at 1700 wave numbers, and a CC double bond stretch at about 1650. The only structure given that has all of these functional groups is the third one. In this last question, you're given 2 structures, 2 constitutional isomers, and asked how you might use IR spectroscopy to distinguish between the 2. So the essence of this question is really identifying the key structural differences and then mapping those onto specific IR vibrations. For example, the first structure is an aldehyde, and an aldehyde will have a CO double bond stretch at approximately 1725 wave numbers. On the right, we have a ketone, which will have a CO double bond stretch at 1715 wave numbers. This structure also has an alkene, and the alkene will have a CC double bond stretch around 1650 or so, and a CH stretch just above 3000 because it's sp2 hybridized. So you would look for these key stretches in the IR spectrum in order to distinguish between the 2 isomers shown.